Hello everyone. Today we're going to continue learning 18.2, defining and evaluating the basic trigonometric functions. And so in day 2, we're going to continue. Yesterday we spent a great deal of time looking at the values of sine, cosine, and tangent of 30, 45, and 60-degree angles in quadrant 1, 2, 3, and 4, and see how the signs take place that will affect the values. It won't affect the values, but affects the signs, which changes from quadrant 1, 2, 3 to 4. So today we're going to continue, and we're going to expand that idea by finding sine, cosine, tangent, the exact values. And so we're going to be able to define and evaluate basic trigonometric functions. And here we go. The first thing is the idea of a reference angle. And a reference angle, basically, just like the name says, it is in reference to. And usually we are relating the angle to either the 180 degrees or 360. So the rule of thumb is in quadrant, if the angle lands in quadrant 2, like this one right here, okay, or in quadrant 3, like this one here, then we would say that because it is closer to the 180, if it's quadrant 2 and 3, it's closer to 180. So we're going to work with the 180 to find the reference angle. And then if the angle lands in quadrant 4, like this one right now, it would be closer to the 360. So we will work with the 360. And by the way, it's not mentioned here, but if the angle is in quadrant 1, then the angle itself is the reference angle. So because the idea of reference angle is less than 90 degrees and it needs to be positive. So two things, remember. It has to be less than 90 degrees and the value of it needs to be positive. So those are the two ideas that drives the reference angle. And finally, the last thing we're going to need is when the angle lands on different quadrants, we're going to refer to the sign using these 4 acronyms. All students take calculus. So remember, all students take calculus. We're going to use this to determine the sign, just like it says right here, because that's a lot of memorization if you were to remember whether sign is positive or negative. So we can just use this idea, all students take calculus. So notice that in quadrant 2, the sign is the one. So in quadrant 1, what this means is in quadrant 1, everything is positive. That means sine, cosine, tangent, anything that you can think of, that trigonometric function is all positive. In second quadrant, only the sign is positive. Notice right here, only the sign is positive. Everything else is negative, right? In quadrant 3, only tangent is positive. And so notice that only the tangent is positive. And then in quadrant 4, only cosine is positive. So that's why cosine is the only thing positive. Everything else is negative. And that's why all students take calculus. So that's what you can take with you even when you go to calculus. So we're going to take a look at how we're going to use that to help us to generate the exact values. So we're going to start with the idea of the reference angle. We're going to practice all of that over and over. It's a process that we go through, but we're going to begin with reference angle. So in order for you to find a reference angle, the first thing we need to do is identify where is the current angle. So 130 degrees, that is more than 90, but less than 180. So it's going to be like something in between here. So I would say this is 130 degrees, right? Would you agree? And so this angle from here to here is 130 degrees. Well, guess what quadrant it lands on? In quadrant 2. And remember, in quadrant 2, it is close to 180, closer to 180 than 360. So the reference angle we're going to use to calculate is 180. So theta prime is what we use for the symbol for reference angle. It's going to be 180. It's always the bigger angle minus the smaller one. So 180 is bigger, minus smaller one is 30. So therefore, the reference angle is 50 degrees. And what we're saying is, hey, you are only 50 degrees away from 180. So that's why the reference angle is 50 degrees. So here is the reference angle. All right. And that's the end of that problem. Part B is another example, and it deals with radian. Now, a lot of people are not comfortable working with radian mode, but you're going to have to eventually get used to it. So you might as well get used to it from the beginning. And you can just take it apart like this. Well, here is 0. 90 degrees power of 2. 180 is actually pi, and then back to 2 pi for 360. So pi, 5 pi over 4, the angle. It is a little bit more than 4 pi because 4 pi over 4 is pi, right? So I know that the angle is more than pi, and it's going to be somewhere over here. So here is 5 pi over 4, right? So the angle from here to here, and guess what? That is in quadrant 3. And in quadrant 3, you are closer to pi instead of 2 pi. So therefore, theta prime, reference angle, is going to be the bigger angle. Now notice this angle is bigger than pi, so we're going to take 5 pi over 4, which is bigger than pi, minus pi, and I'm going to find a common denominator. So 5 pi over 4 minus, now pi is actually 4 pi over 4 when you multiply 4 on top and bottom. So 5 minus 4 is just 1 pi over 4. And so theta prime is pi over 4. So the reference angle is, hey, you are pi over 4 away from pi, okay? Instead of pi over 4 before, it's after. So the reference angle is pi over 4. And that's the end of that. Next example, we have a negative angle. When the angle is negative, guys, we can't find the reference angle yet. We need to unwind the angle and make it positive first. So we're going to find the coterminal angle, and everyone knows how to do that from 18.1, right? You're going to add 360 degrees to make the angle positive. And now I have the angle is 220. I can say, hey, that angle is more than 180. It's like 40 degrees over, right? So here is 220. And so the angle is in third quadrant, guys. And so that means theta prime, which means reference angle, is the bigger angle, which is 220, minus 180, which is 40 degrees. And that is the reference angle. It just means that, hey, you are 40 degrees over the 180. So that's the idea of reference angle. So you should be able to find the reference angle for any angles now. It is time for you to practice those skills that you just learned. So go ahead and pause the video, try the problems on your own first, and then come back and check your answers. Hopefully you've had a chance to try the problems on your own. We're going to take a look and see if you got them right. First angle is 215. Here's 180. 215 is over the 180. So here is 215. The angle is in third quadrant. And in third quadrant, you are closer to 180, not 360, right? So theta prime is actually 215, which is the bigger angle, minus 180, and that gives us 35 degrees. So theta prime is 35. Next, 11 pi over 6. Well, if you actually know your fractions correctly, you should know that 11 pi is almost 12 pi over 6, and that's almost 2 pi. 2 pi is like right here. And here's pi. So 11 pi over 6 is like all the way from here to here, like a Pac-Man. So it is 11 pi over 6, which is in fourth quadrant. In fourth quadrant, you are closer to 2 pi. So the reference angle is going to be 2 pi minus 11 pi over 6. And I know that 2 pi is 12 pi over 6 with a common denominator. And that is how I get pi over 6 as my reference angle. So this space right here is pi over 6. It just means, hey, you're only pi over 6 away from 2 pi, okay? And that's that problem. Last one is a negative angle. Again, we need to unwind this angle by adding 360. So that will make it a positive 120 degree. And that angle is coterminal with the negative 240. So either way, if you go from the left side, you end up with 120. If you go from the right side, you end up negative 240 is still going to be in the second quadrant. So regardless whether you go left or right, positive or negative angle, you end up in second quadrant. And that angle is closer to 180. And so the reference angle is 180 minus 120, which means 60 degrees. So reference angle is 60 degrees. It means, hey, you are 60 degrees away from 180. And that's what the reference angle is. And that's the end of that category. Hopefully you've got plenty of practice, and I'm sure that with the homework later on, you'll have more chance to practice this as well. Let's go ahead and use that concept we just learned with the reference angle to find the exact answer. So whenever it says evaluate without using a calculator. Without using a calculator means you cannot use a calculator, which means you got to do all of this by hand, which is why we learned reference angle, and we also learned the 30, 60, 90 or 45, 45, 90 in the beginning. We've reviewed all of that so that we can put it all together. This is a process that you must go through and you must practice. This is not easy at first, but with practice, it'll only get easier. I promise that. Okay, so first, we're going to need to take a look at the angle. The angle is 420. Well, what does that tell you? That tells you that, first of all, the angle is out of range. It is more than 360 because we only know, within 360. So we're going to unwind this by finding the coterminal angle. Take 420 minus 360, and I should have 60 degree. So that is coterminal. So whether you say 60 degree or 420, if you go 420, whether you go 420 or 60, you end up with the same angle, which is 60 degree. So the angle is actually in quadrant 1, which means when the angle is in quadrant 1, the angle itself is the reference angle. So I know I have theta prime is 60 degree. Now, because I have reference angle, I'm going to find the sine of the reference angle. And so I'm looking for 60 degree, and I need to tap into what we did yesterday with a 30, 60, and 90. Remember the ratios between the three sides? The shortest side is 1, hypotenuse is 2, and the longest side is radical 3. So 1, 2, 3. And so then the 60 degree is what we're looking at. So in terms of 60, sine is opposite over hypotenuse. So then it is radical 3 over 2. And so the sine of 420, let's address the question, is the same exact answer as sine of 60 because those two are equivalent angles. Remember, they're coterminal, they share the same terminal. And that means the answer is going to be the same. And since it is in quadrant 1, it is positive because everything is positive in quadrant 1. And that is the process that you go through to find the exact value. Let's go ahead and take a look at another one. Part B says cosine of negative 120. Again, first of all, the angle is negative. So I'm going to need to unwind the 120 by adding 360. And I'm going to have a 120. What we're saying is negative 120 is the same as 240. So if you go to the left, it's negative 120. If you go to the right, it is 240. And that's actually in quadrant 3 regardless, which means it is closer to 180. So using earlier the concept theta reference, the prime, theta prime, which is reference angle, it is the bigger angle, which is 240. So here is 240 minus 180. And that's going to give me 60 degree. So I know I need to draw another 60 degree. Hey, I happen to have one over here already. Let me just go ahead and recycle this. I'm going to use this one right here. So in terms of 60 degree, I am looking for the cosine. So I'm going to look for the cosine of the reference angle. Cosine is adjacent over hypotenuse, which means it is 1/2. And so I know that I'm looking for the cosine, but I need to know, hey, in quadrant 3, is cosine positive or negative? And that's what I need to refer back to this table right here. Remember this? All students take calculus. This angle is in quadrant 3, right? And quadrant 3 cosine is negative, right? Because here's how I'm going to show you. So you need to get used to writing this. All students take calculus, right? So we know the reference angle is going to give me the value of 1/2. But the cosine, I need to address the question, negative 120, is going to have the same value of 60 degree, which is 1/2. But the angle itself is in quadrant 3. And in quadrant 3, only tangent is positive, which means sine and cosine is negative. So the answer for this is negative. So the answer is not 1/2, but negative 1/2. You can also use your calculator to double check the answer. Go ahead and enter cosine of negative 120 in degree mode, and then you should be able to get negative 0.5 as your answer. So now I have just done a couple of problems using exact value and using special triangles to find the value. You can go ahead and pause the video and try these 2 problems at this time before you look at the answers. Go ahead and do that right now. Hopefully you've had a chance to try the problems. So let's go ahead and find the cosine of 495. Once again, 495 is way out of range, so I'm going to subtract 360 to find the coterminal angle. So 495 minus 360, it should give me an angle of 135. That means these two angles share the terminal. 135 is somewhere in the second quadrant, I believe. 135. It means that's where 495 is. It's in the same exact location, right? So therefore, I'm going to find the reference angle because quadrant 2 is closer to 180. So theta prime is 180 minus 135 because I need to know what this reference angle right here. So that is theta prime. So reference angle is going to be actually exactly 45 degrees. Yay, it's one of the special triangles. So I'm going to draw a special 45, 45, 90. Remember, this is an isosceles triangle, so the legs are 1 and the hypotenuse is radical 2. So I'm going to find the cosine of the reference angle, 45 degree. I always need to start with finding the reference angle and then finding the cosine of the reference angle. Cosine of 45 is adjacent over hypotenuse. Hey, that's just 1 over radical 2. Again, I need to rationalize it by multiplying because I cannot have radicals underneath. So therefore, it's going to be radical 2 over 2. And so therefore, it is going to be cosine 495. The exact answer is going to be the same value as cosine of 45, which is radical 2 over 2. But the cosine of 495 is going to be a little different, maybe. We'll see. All students take calculus. So in the second quadrant, only sine is positive, and we're looking for the cosine. If sine is the only thing positive, that means cosine is negative. So the answer should be negative radical 2 over 2 because it is in quadrant 2, right? Because the angle is in quadrant 2, and in quadrant 2, sine is the only thing that should be positive, which means the cosine is negative. That's the end of that problem. Let's take a look at the next one. The angle is negative to start with. So I'm going to unwind it again by adding 360, which gives me 300 degrees. And 300 degrees is actually in the fourth quadrant. It's right there. And it is closer to 360. So I'm going to find the reference angle by taking 360 minus 300, which gives me 60 degrees. And so I'm going to find the sine of 60 degree to start with. Again, it is a 30, 60, 90. So I'm going to draw 1, 2, radical 3, and I'm looking for the sine, right? Sine of 60 degrees. So here's the angle. Sine is opposite over hypotenuse. So that's going to be radical 3 over 2. And so then the sine of negative 60 degree is going to have the same value, which is radical 3 over 2, but all students take calculus. And so in quadrant 4, that's where the angle is, 300 degree. Quadrant 4, cosine is the only thing that is positive. That means sine and tangent are negative. So sine is negative. So the final answer is negative radical 3 over 2. And that's the end of this problem. So together we've done quite a few of these. So hopefully you're getting more and more comfortable on these. Here's another example. We're looking for special coordinates. So you need to know the exact value of these right here. So let's take a look. First of all, 3 pi over 2. So you should know that 3 pi over 2 is a special angle. It actually goes like this. 0, pi over 2, pi, and 3 pi over 2. But we're looking for, this is actually negative 3 pi over 2. So it goes backwards. So it becomes, use another color. So when you go backwards, it's going negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi, I guess. Same thing. So the exact value is going to be on a special line. So negative 3 pi over 2 is actually this point right here. And in the unit circle, remember, everything is 1 unit. The highest is 1 unit. So this special point coordinate, these are the special coordinates. This one is the point 0, 1. Everyone should know that, right? This is 1, 0. It's a unit circle. And this is 0, negative 1. And this is negative 1, 0. So this point, cosine, sine. So we're looking for the sine, which means the second number. So the sine of that is actually equal to 1. So the special value is 1. And that's the final answer for that problem. Part B, 7 pi over 4. So in the unit circle, 7 pi over 4 is almost 8 pi over 4, and that is 2 pi, right? So it's almost at 2 pi. So 7 pi over 4, I would say probably over there. 7 pi over 4, and it goes from there to there, and it's in quadrant 4. So therefore, tangent, so we're going to find a reference angle first. Reference angle, it is closer, so here's a reference angle, right? It's close to 2 pi, so it's 2 pi minus 7 pi over 4, which is 8 pi over 4 minus 7 pi over 4. That just gives me pi over 4, the reference angle. So now I'm going to find the tangent of the reference angle, pi over 4. And pi over 4, believe it or not, is 45 degrees. So I am actually drawing a 45, 45, 90. You don't believe me? You can go ahead and convert pi over 4 into degree. It should be a 45, 45. So that's 1, 1 radical 2. So the tangent of a 45 angle is opposite over adjacent. Hey, that's just 1 over 1, which is 1. So therefore, the tangent of the original angle, 7 pi over 4, is going to have the same value as 1, which is the reference angle. But let's take a look at the sine. All students take calculus. This angle is in quadrant 4. Here it is, 7 pi over 4 is in quadrant 4. Quadrant 4, only cosine shall be positive, which means tangent is negative. So the answer is -1. All right. Last problem here is cosine of 7 pi. I'm going to clean up a little bit right here. So make some space. So let's draw the angle. We got 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, and finally 7 pi is back over here. So 7 pi is actually on the special line right here, and here is the coordinate. If you draw the unit circle, here is 7 pi right here. So 7 pi is actually the same as pi. They are coterminal angles. And so the coordinate is actually -1, 0. So you're looking for cosine. So this is CS, cosine sine. So the cosine is actually -1. So the answer for that problem is actually -1. There it is. Again, it is time for you to try these problems. So go ahead and pause the video and try the problems first before you look at the answer. Let's take a look and see if you guys got it right. Pi over 4 is actually in the first quadrant. So here is the angle pi over 4. It is in quadrant 1 where everything is positive, right? All are positive. So quadrant 1. And it is 45 degrees, by the way. So the reference angle is the angle itself, which is pi over 4 or 45 degrees. So I'm going to draw a 45, 45, 90 again, so then I can find the value. And this is 1, 1 radical 2. So the tangent of 45 degrees or pi over 4 is actually equal to opposite over adjacent. It is 1 over 1, which is 1. So the answer is actually 1 for the tangent of 45 degrees. That's the end of that problem. That was easy. Sine of 5 pi over 6. Well, if you guys, in case you did not know, 5 pi over 6 is almost pi because 6 pi over 6 is pi, right? So here's 6 pi. Here's a little bit before that. So here is 5 pi over 6. So from here to here. And here is the reference angle over here. So reference angle is equal to pi minus, because you're not quite at pi yet, so it's pi is bigger. So minus 5 pi over 6, and that turns into 6 pi over 6 minus 5 pi over 6. That gives me pi over 6 as the reference angle. And I'm going to find the sine of the reference angle, pi over 6 first. And that's actually, believe it or not, 30 degrees, guys. You can convert it. So once again, I need 30, 60, 90. And that's going to be 1, 2, radical 3. I'm looking for the sine of 30 degrees. So here's 30 degrees. Sine is opposite over hypotenuse. That is 1/2, which means the sine of 5 pi over 6 is going to have the same value, which is 1/2, but I need to check the sine. All students take calculus. And this angle is in quadrant 2, which means sine is the only thing that is positive. And hey, it is sine. So the answer is positive 1/2 because in quadrant 2, sine is positive. And that's the end of the problem. And that's the end of the lesson for today also. So go ahead and get started with your assignments for today. Have a nice day. I will see you next time.